Everyone. Um, for those of you, I recognize many faces here actually, but for those of you who haven't met me, my name is Emil Kvarnhammar. I'm from TrueSec, and if you've seen my presentations before, maybe it's been about hacking Android devices or hacking iOS applications or hacking Mac OS X. Nowadays, I've been working more with distributed systems and actually a lot about cloud, Docker, Amazon EC2, for instance, which I think is extremely interesting from a security perspective. It brings a lot of possibilities, but also a whole new set of challenges for us as developers and operations. And I know that most of you are developers, but I bet that many of you still manage your own environments, more or less. So I think I still think this is very relevant to both developers and operations. We have a blog at truesecdev.com. I know that my colleague Jimmy released this week new material on his research on denial of service attacks on web servers. So if you're interested in security, I definitely recommend going there and read more about that. There's also going to be a new presentation tomorrow by my colleague Fabio Vigiani here at Øredev. It's going to be about, I think the name is You Hold the Keys to the Kingdom, Developers Under Attack. So check that out. I think it's tomorrow morning after the keynote. So secure systems with Docker. In theory, Docker is quite simple, right? How many of you are using Docker today? Yeah, I guess that's why you're here. So in theory, it's about creating containers or instantiating containers based on a Docker image. So what's a Docker image? Yeah, as you know, we have some kind of base image, the from statement at the beginning of the doc file. That's a starting point, right? And on top of that, we add a few operating system packages with yum or apt-get or whatever package manager you're using, depending on what Linux distribution, of course. And finally, the application and maybe a few third-party dependencies, maybe an application container of some sort. And we use that to instantiate one or several containers. Those containers are running on top of the Docker daemon inside some host operating system. In practice, of course, this is a bit more complicated. From a security perspective, we like to think about it from an input source perspective. Where does everything come from? So when instantiating a container, there are basically two different input sources. We have the image itself, and we have the configuration related to that container. As far as the Docker image goes, we have the base image. I talked about the from statement, and the base image is very likely to be retrieved from Docker Hub, right? Some of you might use an internal registry of some kind for your base image. If you do, then that's 1 point extra in terms of security. But I know that very often this is retrieved from Docker Hub while building the Docker image. And in addition to that, more complexity comes in when we add new packages on top of the base image, which is going to be retrieved from the package management service. And that's usually also online, right? depending on what Linux distribution we're using. In rare cases, we might use Red Hat Enterprise Linux. In that case, maybe we have an internal satellite server or something similar. That could be possible for some of you if you're using Ubuntu or whatever too, of course. And finally, the application package. So the application package is something that's not really different compared to a traditional setup, right? But the application package will probably come from a CI server, for instance. And if it's a fat jar, it also includes several other dependencies, probably retrieved from Maven Central or something like that, maybe a Nexus repo. So from an attacker's perspective, this is really a smorgasbord of opportunities, because we have all these different inputs to the Docker image. It might be possible to hijack when the base image is going to be retrieved to the client building the Docker image, but it's more likely that we're able to squeeze in malicious code into the image without anyone noticing. And the same goes for package management servers. And well, you might think that this could definitely happen in a traditional environment as well. Yeah, it could. But the key difference here is, as you all know, in a traditional setup, you more or less always have some kind of golden ISO image that you use for setting up your Linux environment. But in this case, we're going to retrieve a new image each time the image is updated. And all this happens at build time rather than in the production environment. And that's a big difference as well in terms of control, in terms of what processes we have in place. Because we have been working with package management servers and security patching for several years in the production environment, but this is totally different. And this is, again, new opportunities for an attacker. So, but also, we need to think in the second layer, we need to think about what an attacker could do if an attacker gains control over the channel between the Docker image and the host operating system where the Docker image is going to be instantiated, or the configuration related to instantiating that container. Such configuration might come from a script, it might come from Kubernetes, for instance, or whatever orchestration tool that you're using. And finally, one of the most important issues we need to think about and consider as a big risk is if an attacker gains code execution within our application, and that certainly happens, I assure you. If you don't have vulnerabilities in your own code, then there's vulnerabilities in the third-party code and the application servers that some of you are using. And the problem with that is we might think that, but the attack is still containerized, right? That's the whole purpose. So they won't reach anything else. But the thing is, there are several situations where an attacker can break out of that container. And you'll see later how that could be possible. And gain control over the host operating system or gaining control over another container running on the same host. So how do we build secure images? Well, first of all, we need to choose our base image carefully. We need to have a strategy for security patching, because we can't build our container, deploy it, and have it running there for a year, because there's going to be a whole set of security patches during that time period that we'll miss. And that's something that operations can't easily just squeeze into our container. That ruins the whole purpose of having a container, right? So we need to have a strategy for that. And the best strategy is to continuously rebuild and test your containers and have different trigger points. One being that the base image is updated. Another being that some package from your package management service has been updated with a security fix, for instance. Or that your application has a new release. And do this in a secure build environment. More or less everyone nowadays have a CI/CD environment of some sort. So there's no good reason why we should build our Docker containers on a development machine or on a single workstation and push that to production, right? I hope no one does that. And finally, we have the ability to sign our digitally sign our Docker images and verify that signature at runtime. This is as simple as, unfortunately, this is an opt-in feature, but it's just as simple as writing disable content trust equals false. Don't ask me why the naming convention is, it's a bit weird here, right? Disable equals false. Anyway, disable content trust is equals true by default. So I'm going to talk more about the digital signatures later. But one way to secure the management of your Docker images is to set up an internal Docker registry, where you have the different Docker container images in an internal repo. And those images are being pushed from typically a CI/CD environment and then pulled into the host running the containers. So we need to think about setting up, not only setting up a private registry, but also setting it up in a secure way. We need to secure the transfer to and from the registry using TLS, preferably. We need to authenticate the users that are pushing and pulling this registry. And you'll see later why this is so important. We need to limit the access rights. Think about host operating systems in the production environment. There's no point in giving them the ability to push updated images to the registry, right? Our production service should never change what we're running. All that should be immutable by design. And if we're using Docker Content Trust, we can sign the images at build time, and we can verify those images as trusted when we run them in the host environment. From an attacker's perspective, the Docker registry is insecure by default. There are some checks by default by the Docker daemon to ensure that you're actually using TLS. And you can still bypass that by using a flag called insecure registry. But okay, so that's secure by default. But the rest is insecure by default. This means that an attacker can read and modify images as long as they have network access to your private registry. Think about what that means. Think about the attacker inside the host environment. And even if they're containerized, they still have network access, right? So you might ask yourself, but our internal registry, that's behind a firewall. You think that helps? It's very seldom that the firewall does any good today in terms of attacks. When we do penetration tests, the attacks are seldom performed against a firewall. It's more often that weaknesses in applications or in third-party dependencies or in configurations are used in order to gain control over the application, which means that we're inside. Still, with limited access maybe, maybe, hopefully not, in a traditional environment with root access. We might have a non-privileged account, but still we're in. And that's where it starts. Consider if an attacker has network access, then they have the ability to push updated images to the private registry. Those images are then going to be pulled the next time the container is instantiated on this host or on another host. And all of a sudden we've moved between hosts. This is the way real attacks happen. This is the way red team exercises happen, where you spend like 1,000+ hours on trying to gain access to the most important assets of a company, a bank, for instance. So would a firewall help? No. Securing the transfer to and from the registry? No. This can still be done over TLS. Authenticating the users? No. Probably not, at least. Depending on where the credentials are stored, but because the credentials would have to be stored on these host nodes on the right-hand side, because otherwise they won't be able to pull new images, updated images from the registry, right? Limiting the access rights to the registry, that could certainly help, because even if they have credentials, those credentials might not give you the access to push. And Docker Content Trust, signing images, can help. Because what the attacker pushes won't be trusted by this or another node in the cluster. Even worse would be if an attacker would gain control over one of your workstations or the CI/CD environment, whichever computer you use for building your Docker images. And from there, the attacker is pushing updated images to the registry. And those are then being pulled in a similar fashion. So again, firewall, secure transfer, authenticating users, limiting access rights. Even limiting access rights won't help. Because if it's a CI/CD server, then that would certainly need the ability to push updated images to the registry. Docker Content Trust might not even help. Because the keys to sign the images are going to be in the CI/CD environment, right? If we want to have an automated build and continuous release and everything. So the solution here is to secure your development environment, making sure that it's as difficult as possible to gain control over those important assets in your development chain. Think about where the credentials are. That's where the attackers will try to get access. That's partly what Fabio's talk tomorrow is about. So what are the skills required to inject code into a Docker image in the registry? This is just as simple as writing regular Docker files. You just use whatever image you want to use as extension point or what the image you want to update. You add your backdoor binary or whatever you want to change to that behavior. And you build a new image with a tag pointing to that registry, push that updated image to the registry. So that's not very complex. That's by design possible. Insecure by default, remember? So looking at the runtime environment, there are some good things you can do. Unfortunately, this new feature called user namespaces, it's new in Docker 1.10, I think. Unfortunately, this is opt-in behavior or opt-in feature. But the good thing about it is that you can make the root account in your container being different than the root account of your host. because by default, they're the same. It's UID 0. So even if you're containerized, even if you have limited access to the rest of the file system, even if you have limited access to the network stack, for instance, or some of the devices, you're still root. There is a remote API that you can enable on the Docker daemon. There should be a really good reason for enabling this, but I know that some are using it. So if you do, and if you need to use it, then you make sure that you set it up with secure transport using TLS, and that you have client authentication so that you don't let the world in. On the host operating system, you should have SE Linux set to enforcing, at least. This is, in some Linux distributions, SE Linux is enforcing by default, so you don't need to worry about it. But check it out. It's something that's very simple to enable. And I know that some people are concerned that this might break stuff, but you'll definitely notice. So try it out. If it's set to permissive, it's on, but it will never react on anything. It would just silently log any misbehavior. So make sure that it's enabled. And there are a lot of Linux capabilities that are added by default to Docker containers. Drop those. This is just simple command line statement to drop everything and add the capabilities that you think you actually need. Again, you'll definitely notice if you need a capability that's not added to your container when you're testing. And few applications need all those privileges or all those capabilities that are added by default. And finally, only pull images into the production environment from the private registry. Then you have that as a toll gate. You have that as a control point where you know that this is something that's tried and tested, that passed our development environment and our build environment and our testing environment. And stuff can't just magically show up in your production environment because of that it was added to a public repo. There are some things you should avoid in Docker. There is a flag called privileged. That basically means that breakout is extremely trivial. I'm going to show that later. And I talked about the insecure registry. That disables the TLS requirement that the Docker daemon has by default on Docker registry traffic. So don't do that. And finally, net equals host. That means giving the container complete access to the host network stack. In some scenarios, some rare scenarios, this can be very convenient. But this will limit you too much, and it will expose totally new security challenges. For instance, this in combination with the capabilities means that you're able to, from a container, you're able to read and write raw IP packets from the container of the host network stack. So that basically means being the host from a network perspective. And so let's look at some demo stuff on that. I bet you heard that privileged containers or running containers as privileged is not something good. But I'm going to show you why. Let me just get rid of the presentation mode. There. So we have a simple Linux host here. Hope that everyone can see. Just to show you, I'm running as a demo account on this machine. And I'm in the host folder right now. Sorry, in the home folder. So if I just instantiate a Docker container, we'll see that for instance, if I list all the devices beginning with SDA, there are no such devices. And if we'll look at the mount output, see if I can get this right. Looking at what the root directory is mounted to, it's mounted to a sandbox file system, right? So what's the difference when we're running as privileged? Oops. Yeah, this looks interesting. These are not the only new devices we get when we're running as privileged. Let's look at the mount output again. Still sandboxed. Okay, so we're still containerized to some extent. But what if we create a new directory and I just happen to know that it's dev SDA3. Look at that. So all of a sudden we have the host file system mounted with full read-write access as root, even if we are in a container. This is by design, so I'm not using any exploit code or anything, right? This is a big issue. And there are some possibilities in Kubernetes, for instance, where you can turn privileged mode off. So I recommend looking into that. Unfortunately, I'm not aware of any good way of disabling privileged mode for a separate Docker daemon host, because that would be very convenient. So there are some things you can do to improve the security, which is really simple. I talked about user namespaces, and I'm going to show you how to enable that. Just to show you a simple example, I'm running without privilege now. I just ran sleep 30, and if we grep the output of the process list, we see that this is currently running as the root account. So this window is on the host. This is in the container, but still we're root, the same root. If we exit the container and, I need to do sudo. Depending on what Linux distribution you're using as host, this could look a little bit different, but the important here is you need to modify the Docker daemon options. So I'll add user ns3map default. This is going to enable user namespaces for the Docker daemon of this host. And we need to systemctl restart Docker. Boom. And let's try to run the same again. Sleep 30 within the container. And you'll see this process is now as the Docker remap user. So looking at, we can start by Docker remap. So we can see that this is a real account on the host still, but it's a non-privileged account with UID 10,000. Another related file is the sub-UID. This is a list of doc remap, basically a table of user remapping, so that Docker will know that we are free to use the UID 10,000 and a range of 65,000 accounts over that. That should be more than sufficient, right? So this is very simple user namespaces, and all of a sudden we have reduced the attack surface. And the good thing about this, a bonus feature of this, is that it's incompatible with privileged. So if you have user N as remap default, that means you can no longer instantiate as privileged. The bad thing about user namespaces is that I think it was in Docker 1.12, shortly after user namespaces was introduced, all of a sudden they added the ability to turn it off for a single container. So when you instantiate your container, you can still choose to override whatever the Docker daemon has been configured to. That's unfortunate. So this was privileged container breakout and user namespaces. So keep your containers and hosts stateless, because if you do, part of that is limiting the access rights in the image. Use distributed sessions and caches, and avoid mapping host volumes. And if you do, your containers and hosts are going to be more secure, it's going to be easier to upgrade, and it's going to be a lot easier to scale. There's only benefits, and you're going to be like a happy cat. Doing this at scale makes everything, surprise, more complicated. Security in clusters is a mess. You have several different host nodes. You have most likely you have more than one private registry in order to have high availability. You have more than one master node for the cluster, just to keep track of everything executing. You have networking between the different host nodes. You have peer networking between the masters for leader election, for traffic between, to keep those in sync. You have some kind of admin user interface usually. If you're using Mesos, then it might be Marathon. If you're using Kubernetes, then it's the Kubernetes dashboard. You might have an API server that's accessible from the outside. And commands are being sent to some kind of agent in the host nodes. So again, this is another smorgasbord for an attacker. What a mess. To be less abstract, I'm going to show you a simple example in Kubernetes, what this means. So if you have a master node in Kubernetes, in that master node you have an API server, you have a etcd service, a controller manager and a scheduler, Kubernetes controller manager and scheduler. And you have, let's say you have two different host nodes with your application pod running in it. In addition to that, you have a dashboard pod which is used for presenting the admin user interface. The problem with this is that, and this example is illustrated based on a simple setup guide for getting Kubernetes up and running. And it's often like that unfortunately in these setup guides, few of them address security issues related to this setup. So what happens if you have the dashboard pod running on one of these host nodes, then not only do you expose the dashboard functionality to one of the hosts also running applications. Consider what that means. Remember the container breakout. If an attacker gains control over the application, then could they possibly get access to the dashboard? But the dashboard will forward calls to the API server. And in this case, plain text HTTP traffic to the API server without any authentication or authorization. So an attacker would certainly try to attack the admin user interface, even if there is some kind of login to the admin user interface, or if it's limited through a firewall, for instance, it could still be possible to access the API server instead. Or access the etcd server. Because etcd is, in this setup, etcd is keeping track of how the flannel network looks like. So if you're able to affect etcd, the etcd database, then you could add new hosts or to the flannel network, for instance, and all of a sudden you're inside this gray bubble. But the biggest issue here is if the API server listens on address 0000, then that means that the API server is listening both within the flannel network and on the network outside, the network that the master server is added to. So this, again, this is not exploits, it's just by design. So you need to think about all these attack vectors. Think about if an attacker gains access to the application, what it means if they have access also to the API server from the inside. Again, the firewall won't help. It's a mess. To summarize, one important way to make your environment and your systems based on Docker more secure is to have a structured way of building and managing secure images. You need to secure the runtime environment. One of the ways you can do that is using namespaces. SE Linux, for instance, that we talked about. And you should definitely avoid allowing running containers as privileged. Securing clusters is a real mess. Identify all the attack vectors that you can see. For instance, all the different listeners, all the different interfaces that we have accessible within our cluster setup. And unfortunately, few of these setup guides cover security aspects. They might have an example configuration. Your configuration should look something like this. So then it's up to you to add TLS, to add client authentication, for instance. But even if you have client authentication, you need to think about where do we store these credentials. So this is not impossible, but it's complex and it's very dependent on what kind of environment you're using. And there is a lot of good stuff you can do. For instance, to limit so that the dashboard pod doesn't necessarily run on the same hosts as the applications, because that would certainly reduce the attack surface on the dashboard pod at least. That's all I wanted to present to you. So I think I have 1 minute if you have a question. No? All right. You're free to come up after the session, of course, if you want to discuss more. But thank you for listening.